Greetings. Today we're looking at basic trigonometry. First of all, we're gonna study the first three trigonometric laws. If you look at the triangle on the right, you see that it's an angle, an opposite side, an adjacent side, and a hypotenuse. If you try to use trigonometric formula, eventually you get sine, which is opposite over hypotenuse, cos, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So this is just the elementary part of basic trigonometry. If you look on the left, this one are three extra trigonometric ratios. If you look at a cosecant theta, it is the reciprocal of sine, whereas for secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So eventually you need to understand all these first three trigonometric ratios and their respective reciprocals. Now we look into sine law. So how do you get sine law? You first use height as a common variable, and using two sine formulas that have height as a subject. Like example, you have h equals b sine uppercase c and h equals to c sine uppercase b. You combine the both and then you get sine uppercase c over c equals to sine uppercase b over b. And this is useful if there are two sides or two angles are labeled, and you can have like two angles one side and it requires you to find a third angle. This sine law will work. The ratio can be invertible, meaning that the sine functions and the variables can flip upside down. So long as all the ratio for these three have the same value, the sine law will still work. Thus, this sine law is so useful, and it can be used to find the side and angle. Now we look into the law of cosines formula. So if you look at the formula on the right, you have a squared equals b squared plus c squared minus 2bc cos a. That is the formula for law of cosines. And you can have the other three for this triangle. So here's how law of cosines formula work. If you want to find out how it works, first you need to split a triangle into two parts, and then you use the sine formula to make height as a subject, and then you use Pythagoras theorem so that you can use the height as a subject, and then you rearrange the variables. Thus you get the formula for law of cosines. This is useful when there is an included angle. So included angle means it is an angle with two sides labeled. Then the side that you want to find is opposite to the angle, and this is useful when there is one angle and two sides labeled, or all three sides are labeled. So long as you want to find the included angle, just make sure that the side that you want to find the angle is opposite to there. That is how the law of cosines formula work. And if you think this is too long, and just look at the diagram and find out how you use the law of cosines. Now we are looking into the area of triangle. So to get the area of triangle using the sine formula is very easy. First, all you need to do is to look at the labeled diagram right here. All you need to do is just find the height and make it a subject, so that you have h equals to whatever side that is a hypotenuse times the sine and the angle that makes up for this height. So you substitute height with the trig form. Like example, area equals to half times a times h equals to b times sine uppercase c. Then the area you will get is half times a times b sine uppercase c. So this is useful when included angle is involved. And if you think that finding height is too tedious or tiresome, then eventually you can use this formula and find the area of triangle. You see C, right, is an included angle, and this is useful. So any triangle that is like not right angle, you can use this formula. Now let's look into the unit circle. So this unit circle, it looks like this, and this is useful when you want to find out the corresponding trigonometric functions, what kind of resultant value you will get, such as positive or negative. And this is split into 4 quadrants. The top right is first quadrant, top left is second, bottom left is third, and bottom right is fourth. And the enclosed green brackets that you see are those which trigonometric ratios are deemed to be positive. Like first quadrant, all trigonometric ratios are positive. For second quadrant, sine is positive. Third quadrant, tangent is positive. And fourth quadrant, cos is positive. And this can be useful if you want to find out which kind of trigonometric values will give a value in which quadrant. And you can use cosecant, secant, and cotangent, and they follow the corresponding counterparts in the unit circle, like a sine to be cosecant to be positive in second, cotangent to be positive in third, and secant to be positive in the fourth. And you can use the following mnemonics. There's just so many. I included 3. You can have add sugar to coffee, all science teachers crazy, and all students trust Cambridge. You can just use whatever mnemonic that suits you when you want to do your trigonometric practices. Now we look into trigonometric function graphs. If you look at the first 3 at the top, you have sine, cosine, and tangent. These 3 are the standard trigonometric functions that you see. But we will focus on sine and cosine since they are more widely used in applications such as medical, engineering, and this is due to their sinusoid pattern. Others like tangent, cosecant, secant, or cotangent, they use somewhere else. And this visual representation helps you to like recognize the shape of each graph. But I believe that if you use graph plotters such as Desmos, you can see how the graph is plotted out. And this one, you require you to look at the x-axis, where sometimes the x-axis can be degrees or irradians. You just need to look out for that. And if you already try out the trigonometric functions, you see that the sine and cosine have amplitudes, whereas functions like tangent and cotangent do not have. The secant and cosecant have something interesting where at a certain value they cannot intersect each other. So that's basically the nature of each graph. And as I said, we only focus on sine and cosine due to their to the sinusoid pattern, and they are more widely used. Now let's look at the trigonometric graph formula, and this is one of the examples that I put inside here. So you have y equals a sine bracket with bx plus c, and then you have plus d outside of the function. So a is amplitude, and you can get it by having the maximum minus the minimum divided by 2. Frequency is how far apart are the waves from each other, and for sinusoids the period is 2 pi over b. So if you want to find the period, you can use the frequency and then plug in the formula. As for phase shift, is to show where the horizontal translation of the graph. So like the positive will shift the graph to the left, which is leading, and negative is shifting to the right, which is lagging. The D is vertical shift, in which you can find by having the minimum plus the maximum divided by 2. Positive means the graph will translate upwards, and negative translate downwards. And for D, right, okay, what it shows you the shift in the equilibrium state. The equilibrium state, in if D is 0, it will be x-axis example. And this formula can be applied to cosine, since it's also a sinusoid like sine, but it's shifted to the left by half a pi. Tangent function is different due to having asymptotes at half a pi multiples and having a period of pi over b. That's why we mostly focus on sine and cosine because of this. And I believe that is all from me. I will make another video about trigonometry, but it's of a higher level. Thank you.